This question is from GATE Mechanical Engineering of 2014. This is question number 45 of set 1. The question is, in a simple concentric shaft bearing arrangement, the lubricant flows in 2 mm gap between the shaft and the bearing. The flow may be assumed to be a plain Cauchy flow with zero pressure gradient. The diameter of the shaft is 100 mm and its tangential speed is 10 meter per second. The dynamic viscosity of lubricant is 0.1 kg per meter second. The frictional resisting force in Newton per 100 mm length of the bearing is. Now in the problem we have to assume that it is a plain Cauchy flow. So let's understand the Cauchy flow. Cauchy flow is the flow of a viscous fluid in the space between two surfaces, one of which is moving tangentially relative to the other. Suppose this is one surface, so these are the two surfaces and between which the fluid is there. So suppose fluids are here in this, and one of the plate is fixed or one of the surface is fixed and another surface is moving tangentially with some velocity. Because this is a viscous fluid, there will be shear stress generated. Now here this is a case of concentric cylinders. Suppose this is the shaft and this is the outer case of the bearing. Because of the rotation of the shaft, there will be a shear force generated in this. Also the tangential velocity of the shaft is given, okay, and that is 10 meter per second. Okay, so if we draw the velocity profile, it is maximum here and this here it is 0. Now the shear stress in the shaft due to rotation is given by, let's write tau wall is equal to mu du by dy, let it be equation number 1, and shear stress in the cylinder will be equal to shear force divided by the surface area. Let this be equation number 2. Now if we equate these two equations and substitute the values, we can write mu value is 0.1, the dynamic viscosity, the velocity, change in velocity is 10 divided by 0.002, because that is the gap between these two, 0.002 meter. This will be equal to the shear force F divided by the area of the shaft, so this will be pi into 0.1 square. Okay, so from here we can get the value of F, that is 15.71 Newton. Okay, and let's fill in the blank. So the frictional resisting force will be 15.71 Newton. For more information, you can refer to the NPTEL course lecture number 19, Cauchy flow on advanced concepts in fluid mechanics by Professor Suman Chakraborty of IIT Kharagpur. You can also follow the lectures by Suman Chakraborty on flow between concentric cylinders.